Hello, thanks for joining us. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley, your host. So good to have your company yet again. Now, coming up on episode 322, we are talking about some of the things China is up to on the moon. Of course, they've got a few things going on at the moment, but they're also planning 3 new missions. They have also announced the discovery of a new lunar mineral, which they've called Changasite. What is that? We'll find out because Fred knows. Also, NASA, the latest on their attempt to get to the moon, and the fallout, boom, boom, from the Blue Origin rocket crash. We will look at that. And we've got questions from Rebecca about the moon being hit by rocks and what that could do with future moon missions or even a moon base. And Mikey wants to know how we know galaxies are interacting from the photographs we see in the James Webb Space Telescope, because there are so many of them, and how do you know they're getting together or they're not thousands or millions of light years apart? It's a great question. We'll do all that right now on the latest edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. I'm still at large. They haven't found me yet. It's very good.
Yes.
Good news.
You lock yourself away in that little cubicle of yours. Yeah. I mean, you've got everything you need there, really.
I do, yes, that's right. I've got everything here.
Yeah. No need to emerge.
No, never do that.
I'm kind of the same. It's just, I'm happy with me and my trophies.
Yes, that's right.
Really
all your trophies, yeah.
Don't need anything. I don't need food, just the trophies.
Well, you could probably
is.
eat them if the worst came to worst.
Yeah. Now, we've got a fair bit on today, and it looks like thumbs up to China, thumbs down to NASA and Blue Origin at the moment when it comes to the moon. So let's start with China. What's Changasite?
Well, it is a new mineral that, or a newly discovered mineral, if I can put it that way, that has been found among samples that the Chinese, I think it was Chang'e 6 mission, if I remember rightly, returned to Earth in, when was it? I beg your pardon. It was Chang'e 5, which landed in 2020, and then sent them back. I think it was quite a while before they arrived back, if I remember rightly. Yes, Chang'e 6 is the next moon mission. I apologise for the mix-up there. There's a substantial lump of stuff came back with Chang'e 5. Something like almost 2 kilograms of material collected robotically on the moon's surface, which has now been analysed. And among these, samples of lunar soil is a crystal or a new type of crystal. I think they've only found one of them, actually, but it's a material which is being called Changasite. Chang'e, of course, is I think it's the goddess of the moon, if I remember rightly, in Chinese culture. And it's what the whole set of Chang'e missions is named after. But this mineral is, it's interesting because China's only the 3rd nation ever to discover a new lunar mineral. US did it with, of course, material from the Apollo missions, and the Soviet Union had their lunar sample return missions, which I think were in the late 60s, maybe 70s.
Which they've just renamed, actually. It's Putinsite.
I'm not going to go there. The really interesting aspect of this newly discovered crystal is, mineral, is that it could potentially be an energy source. Which is why there's so much interest in it. So it's technically described as a phosphate mineral in columnar crystal, which means it makes long crystals. Apparently they're transparent. Transparent and colourless. But the clue to the idea of it being an energy source is that the mineral contains helium-3, which I think you and I have spoken about before, is extremely rare on Earth. I think it's only produced in nuclear reactors, but is probably fairly abundant on the moon because it is a product of the interaction between the solar wind, charged particles from the sun, and the lunar material. So we think there's lots of helium-3 on the moon, and you don't need much of it to make a nuclear reactor, which is very clean. You can sit it on a tabletop and just run it, and it'll power, 2 or 3 cities. This is, I think, as yet is all future proposals. Nobody's built a helium-3 reactor, but we think it is a possibility and maybe a future source of energy. So that might well, spur nations on to think about mining the moon. People are already thinking about mining the moon, but finding this phosphate-related Changasite mineral is bound to push that ahead, I think, especially for the Chinese. So they are planning I think 3 more uncrewed missions to the moon over the next few years, which is good news. It's always interesting to get, new facilities on the moon.
Yeah, as long as it's cooperative. I don't want them being like school kids playing marbles and they're just going, mine, mine, mine.
Well,
you can't have anything.
Yeah, I'm sure they will to some extent. That's just in human nature, isn't it? But I agree with you. What would be lovely would be to see, these samples that the Chinese have recovered, for example, being distributed around laboratories around the world. I'm sure they're already distributed around laboratories, but I don't know how internationally they've been distributed. When you think about what NASA brought back from the moon in the Apollo era, and admittedly there was 1/3 of a ton of it, so it was a lot of stuff. Those samples went everywhere. They went to just about every laboratory with equipment that was capable of analysing it. So
every state in the US got their own rock, and now they want them back, but there are several missing. From what I've heard,
doesn't surprise me.
Yeah, someone probably shoved it in a drawer and said, "What's this dirty thing?"
Well, it could be, and
just shove it in here. Oh, good paperweight.
Yeah, nice paperweight. Bit dirty.
I wonder about the International Space Treaty, which says you can't own anything outside of Earth, but anything you take from a place you get to keep. Does that mean it's no holds barred on mining?
Yes, that's right. That's exactly the situation, Andrew. That you can't state your claim and say we're going to mine this and nobody else can. That can't happen.
Right. And nobody can own the moon, but they can tear it to shreds.
So the bottom line is anything you bring back from space is yours. But I think that's only legislation that's enacted in a few countries. I don't think it's global. Okay. Certainly in the US, I think in the UK and Luxembourg, if I remember rightly, as well, has that enacted in it.
Got to watch out for those Luxembourgians that are out there.
Well, they certainly are very interested in space commercialization. They see themselves as a global powerhouse of space industry. So not to be taken lightly. I think that change in legislation was something that was seen to probably open the way to attracting more global level commercial interests that are interested in mining space objects to attract them to Luxembourg, to make that their headquarters.
I think the day will come, Fred, where just about every country in the world will have some stake in what's happening beyond the surface of Earth.
The off-planet.
Right now, the major players are the United States, Russia, China, and India's not far behind these days, and a few others. We've got ourselves a new space race now, and I understand that the target areas that NASA are looking at for future walks on the moon and moon bases is the same area that China wants to.
Well, yeah, that's because you're talking about the South Pole region, where there are very deep craters that never get sunlight, and they are thought to have water ice in them. which will be easy to extract. And of course, if you can use solar power to provide an electrolytic cell, you can turn water into hydrogen and oxygen, which not only lets you breathe, the oxygen part of it, but hydrogen and oxygen make rocket fuel. That's the great thing about it. So it's potentially a refueling station for spacecraft leaving the Earth and leaving our vicinity.
Well, that's the plan for future Mars missions, isn't it? To use the moon as perhaps a jump point.
Yeah, and maybe, because of the moon's low gravity, you don't have to use that much energy to get your tanks of hydrogen and oxygen up into lunar orbit. And if you can then rendezvous with a spacecraft in lunar orbit, a tanker craft, fill up your spacecraft, and then head yourself off to Mars, it makes life a lot easier.
Yes, indeed. Yeah, none of that gravity causing all that trouble.
Yeah, that's right. So if you've got to take all your water from Earth, you've got to escape the Earth's gravitational potential. And we've got, as you know, an escape velocity more than 11 kilometres per second. So it's a challenge, which is it's certainly much less than that on the moon. I should check what it is, actually. I'm not sure what the moon's escape velocity is.
It'd be a lot, 1/8, maybe?
Well, it's 1/6 of the gravity. It's probably, that's probably right. It's probably going to be, divide 11 by 6 and you get sort of 2, so that's probably what it is.
Yeah, maybe.
Somebody will look it up.
Yeah, probably, and they'll email us and say, "Well, you were wrong."
Yeah.
Wasn't me.
No, it's me. No, it's all my fault.
While we're on the moon, we should do a NASA update. What's the latest with Artemis-1? Do we have any new information?
We do, yes. That Artemis-1 is postponed again, with difficulties still to do with the fuel system. That there's this issue with the hydrogen being loaded into the launch vehicle, and a leak. That was one thing, but there were other problems as well. But there's actually another issue now, which is a little bit more subtle, and it's basically it's the protocols and the rules and regulations. I'm just so I get this right, I'm going to read from our favourite science news source, phys.org. They've got an article about this on there, which went up a couple of days ago, yesterday, I think, and they're saying NASA's targeting September 27th as the earliest possible date. This is a blog post from NASA. But apparently this date depends, and I'm quoting here, on engineering teams successfully carrying out a test to fuel up the Space Launch System rocket, which we know about, and receive a waiver to avoid retesting batteries on an emergency flight system that is used to destroy the rocket if it strays from its designated range. If it does not receive the waiver, the rocket will have to be wheeled back to its assembly building, pushing the timeline back several weeks.
Oh, my goodness.
Yeah, so it could be... So what we've got at the moment is the possibility of a 70-minute launch window on September the 27th, with a splashdown then on November 5th of the uncrewed Orion capsule. But if that doesn't work, the next window is October the 2nd. So you can see there's plenty of opportunities, but they come in steps. They don't, it's not just, it's all ready to go now, we'll press the button. Yeah. It's all about launch windows, which we've talked about before, Andrew.
And I believe that there is a limit on that. I think they're going to reach a point, if they can't get it off the ground by a certain date, where they're going to have to, roll it back to the shed anyway, because the opportunities will be minimal.
I think there's issues with consumables, with, I guess, batteries and things of that sort, which might well need replaced. They've only got a certain lifetime. I'm not sure what the deal is, but you're quite right that it may well be that we wind up, as we did with that April dry run that was planned. sorry, it was a wet run, wasn't it? They were going to fuel it up and do everything except press the button to launch it, where it was in the end rolled back to the vehicle assembly building, and not. I don't think it finally came back until June. I think that's when the test was completed.
Yeah. They've got to get it right. So better to be careful. Same with the James Webb Space Telescope. It was delayed for a very long time before they got it off the ground. Years, and it, rightly so.
Yeah,
You get it right first time, that's fine. But if you make a mistake out of haste or just because you take a little shortcut here or there, no coming back from that if something goes wrong.
No, especially with something like the Webb, where you've spent decades building the thing and then have it fail to be delivered to its orbital position. That will be a catastrophe. That's right.
Indeed, it would be. Yes. Okay. Well, lots of interest in the moon at the moment, and we, it's pretty exciting. If China has discovered a new mineral that could be a power source, gee, that could be incredible for the future of the planet if they're willing to share. And I hope they are. It'd be good for them because they're pumping out more CO2 from coal-fired power stations than any other country. And we're all talking getting the air clean and reducing fossil fuel use. And wouldn't it be great if they found something that could do it? Would be amazing. Okay, we'll be back to the moon in future episodes, and I don't think that'll be too long, possibly next week. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, another mission that went awry, unfortunately, this one for Blue Origin, was a launch the other day, which saw, unfortunately, the rocket crash, and that's set their plans back. Not only their space tourism plans, but their other missions as well. I think they transport astronauts, do they not? At the very least, they transport goods on some of their Shepard spacecraft. Is that right?
Not to orbit. These are suborbital rockets, Andrew.
Oh,
and
okay.
You're quite right that its main target is the suborbital tourism trade. And Blue Origin's had an incredibly successful track record with this. So the idea is it's the traditional sort of, idea of a rocket with a capsule on top. It's nowhere near as big as a rocket that's going to take you into orbit, but it's pretty, it's standard stuff with, I can't remember whether it's kerosene or liquid hydrogen. I think they use kerosene as the fuel. So a small rocket.
We call it in Australia, Fred, Kero.
Kero, yeah. As we called it in Britain, paraffin. So, yeah.
Right.
Anyway.
It sounds much classier than Kero.
Yes, it does. I might be wrong with that, but I think that's what they fuel it with. So you've got a small version of a standard rocket with a capsule on top, and the tourism venture is essentially a 10-minute flight where the rocket propels the capsule up to something like I can't remember what velocity is. It's almost, I think it's 0.5 kilometre per second, if I remember rightly. And then when you've got it to that speed, you let the capsule go, and the capsule heads out to 100 kilometres before it falls back. And while it is in free fall, you are feeling no gravity. So that's the attraction for tourists. It means that they get a view of the Earth's curvature, and they can float around in the capsule, and then it lands more or less where it took off, but using parachutes. And that's been proven a number of times. They've had a number of paying flights. It's all worked very well. Yeah. In the normal scenario, the rocket itself, once it's projected its payload up to the right velocity, that comes back down and lands on its tail, like the SpaceX Falcon rockets do. But as well as carrying passengers, this particular type of rocket is called the New Shepard. It's its name. It was taken from is it Alan Shepard, the first American into space?
I believe that's right.
That's where the name comes from. And so it not only flies for sending for suborbital flights with crew on board, it also is used for scientific experiments. And that's what this particular flight was doing a few days ago. It was taking up a set of instruments in the capsule. I'm not sure what sort of experiments were there, but they were all robotic, though none of them needed humans to be present. But about a minute into the flight, and you can find the footage, I saw it on space.com, the footage of the flight, the whole flight, which didn't last very long. About a minute into the flight, you can see that something's going wrong. There's a lot of smoke and a wavy vapor trail rather than, the straight line that you expect. And then the whole thing looks as though it's enveloped in flames, but I think that is the jettison rockets firing to take the capsule off the rocket itself, the launch vehicle.
Of course, they have a safety protocol to save the capsule, and it works.
That's right.
I suppose the positive out of it is they managed to test that, and it worked.
They tested it, and it worked. That's right. So it lifted the capsule off, and the capsule made a normal recovery back down to the ground with its drogue chutes opening up, and then its main chutes, and then right at the end there's a little blast of rockets just to slow it down in the last meter or so before it hits the ground, and that all worked perfectly, and nothing was damaged. And of course, if there had been crew on board, they would almost certainly have survived without any issue. So it's an unfortunate accident for Blue Origin, but it has demonstrated that their safety procedures work very well. As a consequence of it, though, the Federal Aviation Administration has grounded all the New Shepard suborbital rockets. That's apparently standard process, and once that's done, then all sorts of investigations will go on to work out what happened before they are granted permission to launch again. So it might be a while before the New Shepard rocket program starts up again. It was, however, the 23rd mission, so they've done very, very well.
Yeah, most of the time in these situations, the explosions happen early.
Yes, well, that's right. Yeah,
the first few missions tend to fall over, but they've had a golden run. And even though this is a setback, I'm sure they'll figure out what happened and they'll be able to make it safer for future missions.
Yeah.
But 23 before you had an incident, it's not a bad record. Not a bad record at all.
It's very good going. That's right.
Yeah, indeed. The thing got up to 1,126 kilometres per hour before the incident occurred. Or it was probably occurring as it was getting to that speed. But that's pulling some G's, isn't it?
Yes, it is. So that's about a third of a kilometre per second, roughly, something like that. And it reached 8.5 kilometres as well, 28,000 feet.
Even if it had people on board, they would have got a nice flight down.
They wouldn't have made it
the moment when all hell broke loose around them, but
because they were so low, the parachutes opened very quickly, so they would have only had a short spell of zero gravity. But I think they might have been glad to get back on terra firma, though, if they had been there.
Yeah. But I guess that means that the experiments and everything are intact, perhaps. And
as far as we know, that's right.
Yeah, they might be able to get another crack at it. So, it's sad news, and they're grounded for the time being, but it does sound like they will be able to learn something from it and safer launches going forward.
Indeed.
Fingers crossed, yeah. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Geez, we're rattling along rather quickly today, Fred, but that's okay because you've got places to be, I've got places to be, we've got things to do. And right now, one of the things we're going to do is take some audience questions. We've got a new batch. You might remember I mentioned the other day that my email wiped itself.
I did, yes.
Without explanation, and I lost all the questions. Well, we got a new batch, so thank you for coming to our aid. The response was amazing. We've got a whole bunch. We're going to go through a couple of audio questions today. First up, we are going to hear from Rebecca in Geelong, Victoria. who is taking us back to the moon. We haven't talked about that today yet.
Hi, Andrew and Fred. This is Rebecca from Geelong in Australia. I have a question about the moon. I was reading recently that there are about 100 asteroids that hit the moon every single day. And because there's basically no atmosphere on the moon, they impact. Is this a concern when we're looking at having a lunar base for future space missions? I look forward to your answer, and thank you so much for putting out this podcast every week. It is wonderful to listen and learn from you guys. Bye.
Bye. Thank you, Rebecca. Gee, that's lovely that you
It is,
feel that way. We really appreciate it, and it's good to have a female perspective. I know we've got plenty of female listeners, but seemingly most of the questions come from blokes. And it's nice to hear from you. And good luck to the Cats in the AFL finals. I know they're still in the hunt. So I think they're in the qualifying final for against Brisbane. I think it's Brisbane. And if they win that, they're in the grand final against the Swans, who still have to beat Collingwood. But, let's just not make assumptions. I think I just did. Now, Rebecca's question is all about the moon and it getting hit at a rate of knots. I have heard that too, that the moon, because it lacks an atmosphere, is unprotected, so it gets pummeled more so than the Earth does, although we get hit a fair bit as well. I think we get hit 30,000 times a year or something, but they're only tiny little things. But what are future missions and maybe moon bases? How do they get around that one?
Well, let's just backtrack a little bit because the 100 that Rebecca mentioned might not be 100 asteroids. It might be 100 tons of meteoritic material hitting the moon, because that's the amount that we think hits the Earth every day. 100 tons of mostly dust particles, but often small rocks and things in between as well, which is a phenomenal amount. That's all raining down on the Earth's atmosphere. But that's what we get by calculating what we think the particle density is in the Earth's vicinity. So 100 tons of stuff. It could be, I think the figure's fairly uncertain. I think it's 50 to 100 is what is estimated. So I wonder if that's kind of what Rebecca means, because most of that stuff is just small dust particles. Admittedly, it's coming in at high velocity. And on the moon's surface, you're absolutely right. You are both absolutely right. There's no atmosphere to cause those bits and pieces to burn up as they do on Earth. We see them as shooting stars or meteors. A few of them are bright. We see them as fireballs. They burn up too, but sometimes the objects are big enough to hit the ground. And that happens on the moon too, and incidentally on Mars. You and I, Andrew, have talked occasionally about new craters that appeared on Mars. They're just a few meters across that they're on one orbital image and not. They're on one orbital image and not the one before it.
I knew what you meant.
Yes, so it does happen, and since most of that material is small, you can build in protection that will actually help to mitigate the effects. But we've got the evidence of 12 astronauts walking on the moon in the 1960s and 70s. We don't think any of them were dinged by micrometeorites, which is what they would be because they hit the ground. There would be micrometeoroids in space. So it is something that mission scientists and astronauts are aware of. And of course, it's the same issue in the International Space Station. You've got the same exposure to this flux of dust particles as you have on the moon and on the Earth. But of course, the difference is, as we've said, the Earth's protected by its atmosphere. Neither the space station nor a lunar station would be. But we know from our experience with the International Space Station, it's done pretty well. It's been quite robust against this kind of stuff.
And the James Webb Space Telescope's been clobbered a few times.
It has, yeah. I think 23 is the last number I heard.
23. The numbers are
23
rising.
times, yeah.
Well, after it's however many years, it might be
look
300.
A bit tattered. That's in an exceptional place, though, remember. It's at the second Lagrange point, and that's going to be a dust it's going to be where dust collects because it's a gravitational null point. So there's probably more dust there than there is falling either on the moon or on the surface of the Earth.
So putting missions back on the moon, putting habitat on the moon, there is a risk.
There's a risk, that's right, but it's pretty low, I think.
Yeah, okay. Would they be able to build habitat that could take a couple of hits?
Yeah, I think you'd stick it underground because that as well is going to protect you from, the sun's radiation, the particles that come from the sun, which are themselves things that can penetrate thin metal. So I think people have certainly talked about any long-term human habitation on the moon will probably be in underground shelters.
Yeah, or maybe in a deep crater. Would that be feasible?
Yeah, that kind of thing, yeah. The kind of thing that people have thought about on Mars is putting them in lava tubes. We know that there are lava tubes on Mars, which is a natural cave that you might want to stick your equipment in and yourself, perhaps.
Yeah, it's a good idea. I'm sure they've got think tanks working on all of this.
They do, yes.
Because not only do they want to put people back on the moon to walk around and go, oh, look, there's Earth. They want to establish moon bases. I'm sure China's got the same idea. I'm sure. Actually, I heard there's probably going to be a joint venture mission between China and Russia, which wouldn't surprise me. But yeah, I think we'll probably have a few nations up there in the not too distant future. Just hanging out, bouncing a ball as high as they can, see what they can do.
Dropping hammers and feathers together to show that they land at the same speed.
Indeed, yeah. All right, Rebecca, I hope we answered your question. Thanks for sending it in. Now we're off to Illinois, and it's Mikey who's got a really good question. This is very perceptive. This comes from a James Webb Space Telescope image, or several images, but I think I know the one he's referring to.
Hey, Fred. Hey, Andrew. This is Mikey from rainy Illinois. So it's 5 a.m. right now. I'm getting ready to start my day, fire up your guys' brand new podcast, and I'm looking at the JWST Epoch 1 image, the mosaic, and in the bottom left corner they have a pair of interacting spiral galaxies. And it brought up a question that I've had, and I always forget it, and it's fresh in my mind, so I'm going to ask it. So how can we tell for sure that galaxies in these images are actually interacting with one another, or that they're not just in the background or the foreground of one another? Because this is just such a big image that there's galaxies scattered everywhere. So I just want to know how, when we're taking apart these images and finding everything in them, like, how do they know that these two galaxies are actually interacting with one another and that they're just not in the background of one another, or, it's just itching my brain, and I'm curious for you guys to explain it. Thanks, guys. Keep up the good work.
Thanks, Mikey. I am looking at the image right now that he's referring to, and I can see what he means. I mean, when you look at the image, everything in it looks individual, and you can't tell whether they're right next to each other or they're, parsecs apart. It's impossible to tell. So how do we glean that from an image, or is there already known science that's been done that already allows for these situations?
I'm just bringing the image up as well, just because I love looking at it.
Yeah.
And astronomers have got a way of measuring the distance to galaxies, and that's to measure the redshift, which is the amount by which the light that left the galaxy has been stretched by the expansion of the universe. So if you look at a group of galaxies, then you can't just make the assumption, exactly as Mikey says, you can't make the assumption that two galaxies nearby are in reality nearby. And there's a classic example of this, which is also in that first tranche of images that the James Webb Space Telescope released back in July, because they put out a beautiful image of Stephan's quintet. I don't know whether you've seen that one, Andrew. It was among the first tranche. And what you've got there is 4 galaxies very close together. Sorry, 5 galaxies very close together, which were, I think the name was given by Herr Dr. Stephan, who, if I remember rightly, it was Austrian, I think. It was a 19th century astronomer who photographed these galaxies, and the 5 of them together look really as though they're all close together, they're all interacting. However, as soon as we knew how to measure the distances to galaxies, we discovered that 4 of Stephan's quintet, 4 members, are at a distance of 290 million light years. But one of them, which looks about the same size, and you would never be able to tell just by looking at it, the other one is only 40 million light years away. So much, much nearer. It's, basically it's an eighth of the distance, or seventh of the distance of the others. And so that's come about because we can accurately measure the distance of a galaxy by means of its redshift. So that will be done for many of the galaxies in that deep James Webb telescope image. And I think I know the interacting ones you're looking at, and I'm pretty sure they'll have been measured to be at the same redshift, which means that they are genuinely interacting rather than just a line of sight effect, which is always an issue. It's always a potential problem. It's the same in our own galaxy when you're looking for double star, when you're looking for binary stars. How do you find a pair of stars that aren't just one behind the other, close together on the sky, but not necessarily close together physically? Once again, it's a matter of measuring the distance. Or actually, in the case of stars, you look for the proper motion. That's their motion through space. If they've got the same motion through space, you can be sure that they are interconnected. So it's all about, not just looking at something, as you would with Stephan's quintet. I'm sure Dr. Stephan, when he looked at it, thought they were all physically connected because that's exactly how they look. But one of them's only a seventh of the distance of the other 4. So you need to have the facts. That's the thing. You can't just make assumptions. And Mikey's absolutely right. You can't just because something looks that way doesn't mean to say that it is.
Yeah. Okay. So it all comes down to redshift. And James Webb is very well placed to be able to analyse the data on that basis with infrared technology on board.
Yep. Infrared spectrometers, that's right.
It's the perfect tool. It's got several tools on it. It's got all sorts of different wavelengths and light capability, hasn't it?
Yeah, there's 4
light speed. It can't do that.
Can't do anything faster than light speed. No, that's right.
Okay, Mikey, thank you so much for your question. Great to hear from you. I know it's been a short program this week, but we had very limited time availability to do the podcast. So we kind of got together at the last minute because our original appointment just wasn't going to happen. As it turns out, we both had something else on.
Yeah, that's good. I'm glad
I had something else.
I'm glad it wasn't just me. Yeah,
it wasn't just you. No. We both sort of ran into brick walls, but we got there in the end. So anyway, thanks for the questions. Keep them coming. If you do have a question for us, send it to us via our website, spacenutspodcast.com or spacenuts.io. Click on the AMA link to send us a text or audio question. Or you can click on the tab on the right-hand side and send us an audio question that way. As long as you've got a device with a microphone, you are set. Smartphones, smart tablets, those things that they used to yell at people with that had the, whatever they're called. Megaphone, that's the word. I couldn't think of it. That doesn't really work. But we could hear you if it's a quiet enough day. Yep. But yes, please keep your questions coming in. And don't forget to leave reviews through your favourite podcast platform. We love your reviews. It really helps to grow our audience, and we just want more and more people getting involved. If you're having fun, why should everyone else miss out? So, we're having fun too. And I'll just remind you that we've got another podcast in our stable now called Astronomy Daily, which gives you a sort of a daily 10-minute-ish news rundown of events in the astronomical world. So that's on the same website, spacenutspodcast.com or spacenuts.io, but it's also starting to appear on all the major podcasting platforms. I think we got accepted by Apple the other day. And I don't know if we told you this, Fred, but Hugh sent me some information back the other day about our respective podcasts. And between Space Time, Space Nuts, and Astronomy Daily, we are holding the top 3 positions in the iTunes science category for podcasting. Space Nuts is number 1, Space Time is number 2, and Astronomy Daily is already at number 3, which I'm gobsmacked. Honestly, I use that word too often, but it's amazing.
Great stuff.
Can't believe it. No. Fred.
I answer to Frank. I get it all the time.
I get called other things too, but I can't mention them on the radio or on the podcast. Fred, thank you so much. It's always a pleasure to catch up with you.
You too, Peter. It's really good to actually, chat every week.
That hasn't happened for a long time.
Speak again soon.
Okay.
It was Dave, wasn't it? Not Peter.
Dave. What do you think of Dave? Got Dave. Peter once there. As long as I'm not called late for dinner. Boom, boom.
No, that's right.
Okay. That's enough. Thanks, Fred. We'll see you soon.
Great stuff, Andrew. Take care.
Fred Watson, astronomer at large, and we thank him for making himself available to us every week. And thanks to Hugh in the studio, who sort of came in at the last second to save us and get us all put together. Now he gets to do the fun job of editing. Worst job in the world. And from me, Andrew Dunkley, thanks for your company. Look forward to catching you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.